Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 7 video on the chapter of cubes and cube roots where I will solve the second test paper 2, that is sample test paper 2. In the previous video I had solved the sample test paper 1 on the chapter of cubes and cube roots. If you have not seen that video, I strongly suggest that you watch that video for a good practice of your on the chapter of cubes and cube roots. So as always for every chapter I prepare and solve two sample test paper 1 and 2 that will give you a good evaluation of your understanding of the chapter concepts. So this is sample test paper 2 on the chapter of cubes and cube roots. This video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's start solving the sample test paper 2 on the chapter of cubes and cube roots. Okay, so I have the sample test paper 2 on the left hand side. There are 10 questions, and ideally you should take 4 minutes to solve each problem. So you must be able to complete all the problems in approximately 40 minutes. On the right hand side, I will solve the problems, and I will, after solving a problem, I will pause for a few seconds so that you can pause the video and take a screenshot of the solution for your future reference. And always try to solve the problems of the test paper yourself first, and only when you are stuck and you cannot solve a problem, then you see the solution video for reference. Okay, let's start solving the problems. Let me quickly check if everything is visible. I hope you can see the test paper and the problems. You can read it properly, even though the problems PDF will be, the link of the PDF of the sample test paper number 2 will be given in the description below. Okay, the first problem says that uh, we are given P is equal to cube root of x square y, and Q is given to be cube root of y square x. Then the value of PQ plus Q cube divided by PQ. Okay, so let's find out what is P cube. P cube will be P is cube root of x square y, this whole cube. This is nothing but x square y, because we know that cube root of a cube of anything, that is cube root of x cube, is x. Also know that uh, um, uh, cube of cube cube of cube root of x is equal to x, Okay, so we have p cube equals to x square y. Also we will have q cube is equal to we have q is equal to cube root of y square x. So q cube will be cube of this, and this is equal to y square x. And also see what is PQ. PQ is equal to cube root of x square y multiplied by cube root of y square x. This is equal to, we know that cube root of x multiplied by cube root of y is equal to cube root of x multiplied by y. So this we can say that PQ will be equal to cube root of x square y multiplied by y square x. This is equal to cube root of, if we simplify the expression inside the cube root, we have x cube and y cube. This is equal to cube root of xy whole cube, and this is equal to xy. So we have found p cube, q cube and pq. This implies therefore p cube plus q cube divided by pq is equal to, p cube is x square y and q cube is y square x and pq is xy. From the denominator, if we take from the numerator, if we take xy common, we get xy, and we have x plus y divided by xy. So xy cancels out. We have the final result as x plus y. X plus y. So the correct choice is D. The correct choice is D. Okay, let's do problem number 2. Problem number 2 is, it is given cube root of 166,375 is given to be 55. Then we are asked to find the value of cube root of 166.375 plus cube root of 0.66375 plus cube root of, we have 0.30 and then 166,375. So the value inside the cube root, all the values are the number 166,375 and divided by some power of 10 because it is in decimal form. Okay, so this will be equal to, we can say, the number 166.375. This decimal number has 3 places of decimals. So in the fraction form, it will be 166,375 divided by 10 cube, because the decimal number has 3 places of decimals. When we convert a decimal number into fraction, the numerator becomes the decimal number, ignoring the decimal point, divided by 10 to the power. The power of 10 will be the decimal places of the decimal number. Similarly, the second term will be 166,375 divided by the decimal number is 0.166375, where the decimal places is 6. So it will be divided by 10 to the power 6. The third term similarly will be 166,375 divided by, the decimal number is 0.000166,375. The decimal places is 9. So it will be 10 to the power 9. Okay. Now we know that the number 166,375 is a perfect cube because it is already given. Cube root of 166,375 is 55. This is given. So, and also all the powers of 10, we can see all the powers of 10 are multiple of 3, which means that all the powers of 10 are also perfect cube. We know that any number, we know that for a natural number x, x to the power 3m, where m is also a natural number, this x to the power 3m, will always be a perfect cube. Okay, so now we will apply the concept cube root of x by y is equal to cube root of x divided by cube root of y. So this the first term will be cube root of 166,375 and divided by cube root of 10 to the power 3. The second term will also be cube root of 166,375 divided by cube root of 10 to the power 6, and the third term will be cube root of 166,375 divided by cube root of 10 to the power 9. Now this becomes the first term. The cube root of 166,375 is given to be 55. So this is 55, and cube root of 10 cube is 10 plus all the numerators of the three terms will be 55, and the denominator of the second term will be cube root of 10 to the power 6. We know that cube root of x to the power m, where m is some integer, some power integer, this is equal to x to the power m by 3. So the denominator of the second term will be 10 to the power, the power will be 6 by 3, that is 2. And for the third term, the numerator will be 55 and the denominator will be, we are having cube root of 10 to the power 9. So it will become 10 to the power will be 9 by 3, which is 3. So 10 cube. So this becomes 55 by 10 is 5.5, and 55 by 10 square, that is 55 by 100 is 0.55, and 55 by 10 cube is 55 by 1000, which is 0.055. So this becomes we have to add 5.5 and then 0.55 and then 0.055, which we have 5 and 10 and 6 and 5.605 is the value of the given expression, 5.605. So it is not matching with any choices. I must have done something wrong. So the cube root is given to be 55. Okay, so 55 by 10 and 55 by 10 square and 55 by 10 cube. Okay, so 55 by 10 is 5.5, 55 by 100 is 0.55, and 50, oh sorry, I'm doing silly mistake in calculation. The addition was wrong. It is 6.605. No, I will 5.5, 0.55 and 0.055. Let me do it again. So this is 0, 0, 0. So we have 5, of course 5, and 10, 10, 11, and 6, 6.105. 6.105 is the answer, value of the given expression, 6.105. So the correct choice is B. B is the correct choice. Okay, let's do problem number 3. It is given that let two five 920 multiplied by n is a perfect cube. Then what is the smallest value of n? Okay, now definitely the number 25920 is not a perfect cube, because if a perfect cube has it end with 0, it must at least end with 3 zeros, and it should always end with a number of zeros which is multiple of 3. And the number of zeros in a perfect cube, uh, if a perfect cube ends with zeros, the minimum number of zeros that it will end with is 3. So definitely 25920 is not a perfect cube. So it is asking basically what is the least number n that need to be multiplied to 25920 to make it a perfect cube. Okay, so we have to find the prime factorization of 25920. Let's start with 2. We have 1 and 12960. Then we have again 2, 6, 4, 8, 0. Then we have 2. I think it will divide by 8 also. Let's try to make the calculation fast. So it will divide by 4, 8, 1, 0, 8, 1, 0, and it will divide by 9, 90, again 9, 10, and 2, 5. Now you should be very careful in doing the prime factorization of the given number. Let me check it once again if I did it correctly or not. 2, 1, 2, 9, 8, okay, 2, 6, 4, 8, 0, 8, 64, 1, 0, then 9, 9, okay, and 10, 2, 5, okay. So 25920 is prime factorization will be, we are having 3 2's, we can already see 3 2's. So let's create the triplet, and we can see 8 will also create a triplet of 2 into 2 into 2. Then we can see 2 nines, so 9 can be 3 into 3, and there is another 9, 3 into 3, and we see 2 and 5. So we have to find the least number that needs to be multiplied with this number to make it a perfect square. Okay, now again we have 4 3's, so we can create a one triplet out of the 4 3's, and 1 3 will be left behind. So we can see there are 3 triplets. There are 3 triplets formed, and the factors which are not part of any triplet are 3, 2, and 5. So definitely the number that need to be so definitely the least number, which is n, that need to be multiplied with 25920 to make it a perfect cube will be 3 multiplied. Okay, so it will be, we have to multiply 3 with we have to create the triplets. Whatever the factors we are having, which is not part of the triplets, which are in this problem 3, 2, and 5. From these factors, we have to create triplets by multiplying some some prime factors. So definitely to make a triplet, we have to multiply with 9. So that is 3 into 3 into 3. Okay. So we multiplied by 9, and to make the triplet of 2, we have to multiply with 4, that is 2 into 2, and also to make the 5 a triplet, we have to multiply with 5 multiplied by 5. So the number, so n, this is not n, sorry, this is not n. The factors which were not part of the triplet was 3 and 2 and 5. We have to create a triplet of 3's. to create a triplet of 3's from 3, we have to multiply it by 9. And to create a triplet of 2's from 1 2, we have to multiply it with 4. That is 2 into 2, 4. And to create a triplet of 5's from a single 5, we have to multiply it with 2 5's. So 5 into 5 is 25. Let 25 be a perfect cube. Then what is the smallest value of n? So the answer in my case should be 9 into 4 into 25. It is a big number. Let me check if I did the prime factorization correctly or not. 25920. What is the smallest value of n? Oh, I'm sorry. I'm sorry. These two will not be there. These two already there was 3 2's. So I've already considered the 3 2's in the first triplet, and there was 8. So the second triplet is for the 8, and in the prime factorization, the 3 2's that we can see that has been considered in the first triplet. So these two will not be there. So the factors that are not part of of any triplet is are 3 and 5. As we can see, 3 and 5 are left behind. So what is the number that we have that what will be n? What should we multiply? What will be n, so that when it is multiplied with 25920, it becomes a perfect cube. So basically, what we have to do is we have to create a triplet of 3's from the single 3. We have to create a triplet of 3's from the single 3 by multiplying with 3 2 times. That is, we have to multiply with 9. We have to multiply with 9. 9 9 3 3 9. And also, to create a triplet out of a single 5, we have to multiply it with 2 5's. That is, we have to multiply with 5 into 5, 25. 25. So we should multiply so n should be n should be 9 multiplied by 25. If the question was then what is the smallest value of n? If the question was true 5, what is the least value of n? That must be what is the least value of n, which by which the number 25920 is to be divided to make it a perfect cube. Then the answer would have been 3 into 5, 15. But it is asking the least number of n, which when multiplied with 25920 will make it a perfect cube. We can see that in the prime factorization of 25920, only the factors 3 and 5 are not part of any triplets. 3. So so the answer should be, in my case, 9 into 25, that is 45. 225 should be the answer. It is not there in the choice. Okay, I am putting a question mark. I will come back to this problem later on. Let's move on to the next question. Problem number 4. We have to evaluate cube root of 339 plus cube root of 59 plus cube root of 125. Now this is equal to cube root of, now let's do it step by step. Okay, so this is equal to cube root of 339 plus cube root of 59 plus cube root of 125. Now cube root 125 is 5 cube. We know that 125 is cube of 5. So this now becomes cube root of 339 plus cube root of 59 plus cube root of 5 cube is 5. Cube root of 5 cube is equal to 5, as we know that in general, always remember that in general nth root, now cube root, this is a root, which is when we put 3, when in the top left corner we put 3, it is the cube root. So if we put n in general, this is the nth root of x to the power n is always equal to x. Nth root, this is nth root of x to the power n, which is always equal to x. So now this becomes cube root of 339 plus cube root of 59 plus 5 is 64. This is equal to cube root of 339 plus 64, we know, is 4 cube. So this becomes cube root of 339 and cube root of 4 cube is 4. This equals to cube root of 339 plus 4 is 4 is 3 of 43, and we know that 343 is the cube of 7. It is cube of 7. So the answer is 7. Answer is 7. So the correct choice is B. B is the correct choice. Okay, let's do problem number 5. An equation is given, that is cube root of 4 plus 1.12 divided by 10 to the power n is equal to 0.2 cube of 0.2, 0.2. Now, okay, now let's simplify the left hand side a little bit further. What is 4.4 plus 1.12? That is 5.12, and we can see that 512 is a perfect cube, that is, it is a cube of 8, and we have 10 to the power n. This is equal to, given to be 0.2 cube. 0.2 is 2 by 10 in fraction form, and we have whole cube. So this implies cube root of, now 5.12, we can write it in fraction form as 512 divided by 100, and we also have the 10 to the power n. So this is equal to 2 by 10, or 2 by 10 whole cube, that is it is a cube of fraction. We can say it is equal to 2 to the power cube divided by 10 to the power cube. That is applying the concept x by y, that is applying the concepts laws of exponents or even cubes of rationals, that x by y cube is equal to x cube divided by y cube. So now this implies, now we can write we can simplify the left hand side as cube root of 512 divided by cube root of we have in the denominator was 100 into 10 to the power n. 100 is 110 square, so this is 10 to the power n plus 2 is equal to 8 by 10 cube. Now this implies cube root of 512 is, we know that 512 is 8 cube, and cube root of 10 to the power n plus 2 is, let it be cube root of 10 to the power n plus 2. We have equals to 8 by 10 cube. Now this implies cube root of 8 cube is 8. So 8 by cube root of 10 to the power n plus 2 is equal to 8 by 10 cube. Now we can cancel 8 from both sides, and doing cross multiplication, we can equate the cross products, and we will have cube root of 10 to the power n plus 2 is equal to 10 cube. Now cubing both sides, or we can say if I take the power of 3 on both sides, I will get cube root of 10 to the power n plus 2, and if I will take a cube of both sides will be equal to 10 cube and cube. So this implies, we know that we have already discussed that cube root of x, if you take cube root of x is equal to x. So we have, this implies 10 to the power n plus 2 is equal to, on the right hand side we will have 10 to the power, we have two levels of power, both the powers are 3 and 3, so the products will get multiplied. So this is 10 to the power 9. So now we have exponential term on both the sides, left hand side, and the LHS and RHS both are exponential terms, and we have the unknown n in the power, and the base are same, so we can equate the power. So we have n plus 2 equals 9. This implies n equals 9 minus 2 equals 7. So the value of n is 7, and the correct choice is B. Okay, let's do problem number 6. Problem number 6 says, for prime numbers xyz and natural numbers mn, what is the least number by which x to the power 3m plus 2 multiplied by y to the power 6n plus 1 multiplied by z must be divided to give a perfect cube? Okay, so xyz are prime numbers. Okay, so that is and the number given is in the form of prime factors, product of prime factors, since powers of prime factors, and since xyz are prime numbers and the m and n are natural numbers. Okay, so the given number is x to the power 3m plus 2 multiplied by y to the power 6n plus 1 multiplied by z. So we can see this is a product of 3 primes, powers of primes. xyz are prime numbers, and we are having powers of these primes, where the power of x, prime factor x, is 3m plus 2, the power of the prime factor y is 6n plus 1, and of course the power of the prime factor z is 1. Now we can simplify this, rearrange this in the as x to the power 3m multiplied by x into x in the x square, or rather say x square, and we have y to the power 6n multiplied by y, and we have multiplied by z, Now, you know that an exponential term where an exponential term, let's say a to the power power of the form 3m, where m is some natural number, 3m will be a multiple of 3. So this number a to the power 3m, where a is some, let's say a is some prime factor, a is some prime number. So a to the power 3m will obviously be a perfect cube, because this can be rewritten as a to the power m and whole raised to the power 3. So anytime, and a to the power m, a is a prime number and m is a natural number. So a to the power m will obviously be a prime, will be a natural number. So any natural number, cube of any natural number is obviously a perfect cube. So a to the power any natural number of the form, any exponential term of the form a to the power 3m, where m is some natural number. So 3m will obviously be a multiple of 3. So a number in the exponential form where the power of the exponential term is a multiple of 3 and the base is a natural number, that exponential term is always a perfect cube. So we can say that uh, x to the power 3m is a perfect cube. This implies x to the power 3m can be arranged in triplets. Similarly, y to the power 6n, n is a natural number, 6n is also a multiple of 3, is a perfect cube. Now perfect cube, why? Because 3m is a multiple of 3. Y to the power 6n is a perfect cube as 6n is a multiple of 3. So this implies y to the power 6n will form triplets. That is, all the factors of, that is y to the power 6n means 6 y multiplied by y 6n times, and since 6n is a multiple of 3, all these y's can be arranged as triplets. So the only factor left behind which is not part of the triplet will be x square, y and z. So this implies x square multiplied by y multiplied by z is the factor, or rather x square comma y comma z are the factors that are not part of any triplet. So we know, we have already done this kind of problem, that if a given number, from a given number, if we are asked what is the least number that a number must be divided to make it a perfect cube, we do the prime factorization of the given number and we figure it out. We form triplets and we figure it out, all the prime factors, all the factors which are not part of any triplets, and the product of those factors is the least number that need to be divided with a given number to make that given number a perfect cube. So in this problem, the least number that need to be divided by with the given expression number will be x square multiplied by y multiplied by z, which is equal to x square y, z. So this is the least number in terms of x, y, and z by which the given number must be divided to make it a perfect cube. So the answer is choice B. The answer is choice B. Okay, let's do problem number 7. It is given for integers x and y, where x is greater than y. If xy is less than 0, then which of the following is correct? xy is less than 0, and the given information are xy is x multiplied by y is less than 0, and it is given that x is greater than y. Now this xy less than 0 implies that x and y are of opposite signs, because product of two numbers of opposite signs only makes it a negative value, and the product of similar signs, if two x and y are both positive, the xy will be positive. If x and y are both negative, then x multiplied by y will also be positive. So only when x and y are of opposite sign, their product will be negative, that is less than 0. So xy less than 0 implies that x and y are of opposite sign. X and y are of opposite sign. Now this also implies that x has to be greater than 0 and y are greater less than 0, as it is given that x is greater than y. Now if you just imagine, if you consider one has to, they must be of opposite sign. Now if x is less than 0, then definitely y has to be greater than 0. In that case, x cannot be greater than y. For x to be greater than y, it has to be the case that x is greater than 0 and y is less than 0. So we have found this information from these two given information, that we now know that x is greater than 0 and y is less than 0. Now we have to check which of the following choices is correct. Let's check it out one by one. Now it is saying that cube root of minus x is greater than cube root of y. Now x is a positive number, minus x will be a negative number. So cube root of minus x will be a negative number. Also, we know that y is a negative number, so cube root of y will also be a negative number. So how do we know that cube root of x? We know that x greater than 0 implies that minus of x will be less than 0. This implies that cube root of minus x, we know that cube root of a negative number is always a negative number. So since minus x is a negative number, so cube root of minus x will also be less than 0. And also we know that y we have already found out to be less than 0. So cube root of y will also be less than 0. Now how do we know? So both cube root of minus x and cube root of y, they both are less than 0. But how do we know which is smaller or larger? The choice A is saying that cube root of minus x will be larger than cube root of y. It will not be always true. It will not be always true, because let's say if x is equal to 8 and y is equal to if x is equal to let's say 64 and y is equal to, let's say, minus 8. If we are trying to find some values of x and y that will contradict the the relation, the contradict the choice A. Choice A is saying that cube root of minus x will be greater than cube root of y. So we are trying to verify whether this is correct or not. We are trying to find some values of x and y that will contradict this relation. So if we take x equals to 64, which is x is greater than 0 and y should be less than 0, if we take y equals to minus 8, then cube root of minus x, cube root of minus x, it becomes equal to cube root of minus 64. This will be equal to minus 4. This will be equal to minus 4, and cube root of y will be equal to cube root of minus 8, that is equal to minus 2. Now we can see that minus 4 is less than minus 2. So this implies, in this case, with this example, we can see that cube root of minus x is less than cube root of y. So it is not necessarily always true that cube root of minus x will be greater than cube root of y. So this is not a correct choice, because in some cases it will fail. There are cases where cube root of minus x can be less than cube root of y, as we just found with x equals to 64 and y equals to minus 8. So choice A is the wrong choice. Let's see what is choice B saying. B saying cube root of x multiplied by cube root of y is less than x y. Cube root of x and cube root of is less than x into y. Now now x into y will be a negative number. So this basically means that it is saying that cube root of x multiplied by cube root of y is nothing but cube root of, we can say, x into y. So it is trying to say cube root of xy is less than xy. Is less than xy. I don't think so, because if you take the same example, x as 64, x as let x 64 and y equals to minus 8. So cube root of x into y is equal to cube root of x is 64. X is 64. X is 64 and y is minus 8. Y is minus 8. So this is equal to, we know that cube root of 64 is 4 cube and minus 8 is minus 2 whole cube. So this will be equal to minus 8. So cube root of x into y is minus 8 if we consider x as 64 and y equals to minus 8. Now let's see what is x into y. X into y will be 64 multiplied by minus 8. This is equal to minus 512. Now clearly we can see that minus 512 is less than minus 8. So this implies that or minus 8 is greater than minus 512. So this implies that cube root of xy is greater than xy. Is greater than xy. So with a contradictory example, by contradiction, by assuming x equals to 64 and y is equal to minus 8, we just see that we just saw that cube root of x multiplied by cube root of y is not less than xy, but it is coming to be greater than xy. So this choice B is also not correct. What about choice C? It is saying that cube root of x is less than cube root of minus y. Now x is a positive number. We have already found from the given information that y is less than 0 and x is greater than y, and y is less than 0. Okay, so now this cube root of x is greater than 0 as x is greater than 0, and also cube root of minus y, cube root of minus y will also be greater than 0 as y is less than 0. As y is less than 0, if y is less than 0, then minus y will be greater than 0. So cube root of minus y will also be greater than 0. So both cube root of x and cube root of minus y are greater than 0. But how do we know? How do we ensure? Can we ensure that cube root of x will be less than cube root of minus y? Will it be always true? If we consider the same example as x equals to 64 and y is equal to minus 8, will this relation hold? That is, cube root of x will be less than cube root of minus y. If we let x equals to 64 and y equals to minus 8, uh, cube root of x is equal to cube root of 64, that is a 4, and cube root of minus y is equal to cube root of minus 8, that is a 2, that is 2. And we can clearly see that 4 is greater than 2. This implies that cube root of x, which was coming out to be 4, is greater than cube root of minus y, which was coming to be 2. So it cannot be case that there are cases where cube root of x will be greater than cube root of minus y. So choice C is also an incorrect choice, and definitely the only choice left is D. So it has to be the case that choice D has to be the correct choice, which is cube root of x and xy is greater than xy. Cube root of xy is greater than xy. Now, uh, now why? Mm, I will not explain why the choice D is correct. That is, cube root of x and y is greater than xy. For where we know that y is less than 0 and x is greater than 0. I mean, from the very fact that xy is less than 0, we can say that um, xy. Let me see if I can try, if I can explain. So choice D, why choice D is correct? That is, y cube root of x multiplied by y is greater than xy, where we know that xy is less than 0. From the only fact that xy is less than 0, how can we say that uh, uh, cube root of x into y is greater than xy? Or in general form, if let's say if z is less than 0, this will imply that cube root of z is less than z. Sorry, not less, but greater than z. If we have z less than 0, then the cube root of z will be greater than z. Why is it so? Now, this is because let 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 since z is a negative number, we can assume let z equals to minus t. One second, friend. Please give me a moment. Okay, sorry. Uh, so we were discussing that if z for a number z less than 0, uh, let's say z is a perfect cube. Let's say z is a perfect cube. So and not perfect cube, because if z less than 0, a perfect cube is a natural number which is always greater than 0. Let's say, okay, so z is less than 0, then a cube root of z will be greater than z. Why is this so? So if z is less than 0, we can say that we can assume that z to be equal to minus t, where for some t greater than 0. So t is a positive number. So in that case, minus t will be a negative number. So we are assuming that z equals to minus t. Okay. So t is a positive number. Okay. Now we know that cube root of we know that cube root of, since t is a positive number, we will always have cube root of t less than t. If you take a positive number, its cube root will always be less than the number itself. This is from very common sense. So cube root of t, for a t, for where t is a positive number, its cube root will always be less than t. Okay. Now uh, okay. Now now we have a cube root of z is equal to uh, z we have assumed to be minus t. So cube root of z is equal to cube root of minus t, cube root of minus t. This is equal to, we know that, negative of cube root of t, negative of cube root of t. So cube root of z is equal to negative of cube root of t, where we have assumed that z to be equal to minus t for some positive t, and also z is equal to minus t. Z is equal to minus t. Now uh, one fact that you must understand is that if it is given x inequality relation is given, let's say x greater than y. If this is so, if you change the sign of both the terms, that is x and y, the inequality sign will get changed. That is, this implies that minus x is less than minus y. Also, if x is less than y, this implies minus of x is greater than minus of y. Now we know this that cube root of t, for any positive t, cube root of t will be less than t. From here we can say, if you take the negative of both sides, if you take the negative of both sides, we can say negative of cube root of t will be greater than negative of t. This implies, what is negative of cube root of t? That is cube root of z. And what is negative of t? That is z. So we just prove that cube root of z will be greater than z. Okay. So this was question number 7. Okay. Let's do problem number 8. Problem number 8 says that it is given cube root of x plus 1 by cube root of x is equal to 325 by 18. then the value of x is, we have to find the value of x. We are given cube root of x plus 1 by cube root of x equals to 325 by 18. Now, you can see now we have to find x. How can we find x? Now, taking cube of, since on the left hand side we are having cube root of x, if you take cube, if you take the whole cube, that is a cube of cube root of x plus 1 by cube root of x, if you try to take cube on both sides, the right hand side taking cube will be a lengthy task, because 325 cube is a very long number. So that method, that is taking cube of both sides, will be incorrect. We have to think otherwise. Now you can see that on the left hand side it is cube root of x plus the reverse of reciprocal of cube root of x. So, and on the right hand side it is 325 by 18, which is a improper fraction, and we know that an improper fraction can be expressed as a mixed fraction. So a mixed fraction is like a and b by c, where b by c is a proper fraction and a is a whole number. This is equal to basically a plus b by c, a plus b by c, and a is a whole number and b by c is a fraction. Now, if so, let's see what is 325 by 18 in a mixed form. So if you divide 325 by 18, what do we get? 1, 18, 14, 1, and 5. What will be 6? No, 7, 8, 8, 4. Yes, 8. 8 is 64, 144. Fun. So 325 by 18 is nothing but 18 and 1 by 18. Now you will understand, you will get some clue that the mixed form, the whole part is 18 and the fraction part is 1 by 18. So this is nothing but 18 plus 1 by 18. Now just by seeing the pattern, on the left hand side it is cube root of x plus 1 by cube root of x. So we can clearly say this implies, just by seeing the pattern on the right hand side is 18 plus 1 by 18, and on the left hand side it is cube root of x plus 1 by cube root of x. So just by seeing the pattern and matching the both sides, we can say that cube root of x will be equal to 18. So this implies, if you take the cube of both sides, that is, if you take cube of both sides, we get this. Now cube root of x is nothing but x. So we have x equals to 18 cube. X is 18 cube. Now you have to find what is 18 cube. So 18 into 18 was 144. 18 into 18 was 144. So we have to again multiply with 18. 144 multiplied by 18 is 32, 32, 35, and 11, and 144. So this is 2592. 2592, and it is not matching. What is wrong? 18 into 18 is 144. Okay, and 144 multiplied by 18 is 32, 32, 35, 11, 144, 2952, 2592. Why it is not matching? Cube root of x, 64, 32. (18 into 18 is so cube root of x we can say is 18. So definitely x will be equal to 18 cube. then the value of x is what is 18 into 18? 18 into 18, oh sorry, 18 into 18 is not 144. What I am doing? 18 into 18 is, let me see, what is 18 into 18? 18 into 8 was 144. So 18 into 18 is 64, 144, and 18, that is 4, 324. So 324 again multiplied by 18 will be 32, 16, 19, 25, and we have 3, 2, 4, which is 2, 3, 7, 5, 5, 7, 3, 2. What happened? 5, 7, 3, 2. This is equal to 5, 5, 7, 3, 2. Oh, sorry. 5, 8, 3, 2. It will be 5, 8, 3, 2. So 5, 8, 3, 2. This is the value of x. So the correct choice is D. D is the correct choice. Okay. Let's do problem number 9. If x and y are whole numbers such that y to the power x, it is given y to the power x is equal to 1, 9, 6, 8, 3, and it is given y greater than x, and it's also given x lies between 1 and 4, that is x can be either 2 or 3. Then this we have to find the value of x root of y. We have to find this. And this is nothing but y to the power 1 by x. So this thing is x root of y, which is equal to, we know that nth root of x. This is nth root of x, which basically is nothing but x to the power 1 by n. So x root of y is nothing but y to the power 1 by x. We have to find the value of y to the power 1 by x, where it is given y to the power x is equal to 19683, and y is greater than x. And x is between 1 and 4. So the fact that x lies between 1 and 4 implies that x is 2 or can be 2 or 3. The possibilities of values of x is 2 or 3. Now see, if so, the only possibility of the value of x is 2 or 3. Now if x equals to 2, this implies that if we put it in the given first equation, that is y to the power, this will imply y to the power square is equal to 19683. If we consider the value of x to be 2, then it is given that y to the power x is equal to 19683, which means y square, since x is 2, is equal to 1963. This cannot be the case, because we know that square of any natural number cannot end with the digits 2, 3, 2, 3 or 7 or 8. Any natural number ending with the digits 2 or 3 or 7 or 8 cannot be a perfect square. So since y is 19683 cannot be a square, so x cannot be 2. So this implies x cannot be 2. This implies x has to be 3, because the only possibility of values of x is 2 or 3, since x lies between 1 and 4. So x has to be equals to 3. So this implies we must have y cube is equal to 19683. Now, so this implies that what will be y? Y has to be a cube root of 19683. If y cube is 19683, it means that cube root of 19683 is y. So this is this. Now we have to find okay, so why is this? Fine. Now we have to actually find the value of y to the power 1 by x, which is equal to x. We have already found that x will be equal to 3. So this is equal to y to the y to the power 1 by 3. Now what is y? Y is cube root of 19683. This whole to the power 1 by 3. So this is nothing but 19683 whole to the power 1 by 9. So basically we have to find the cube root of 19683, whatever that value cube root is, we have to find the cube root of again that value. So we know that we have found that y is equal to cube root of 19683, and we have to find the value of y to the power 1 by x, and x we have already found to be 3. So we have to find y to the power 1 by 3, which is equal to cube root of y. So we have to find, so we know that y to the power, the expression that we have to find value of is y to the power 1 by x, which is x root of y. So this is, now we know, as we know that x is 3, this is x y to the power 1 by 3, which is nothing but cube root of y. So we have to find cube root of y, where we know y is equal to cube root of 19683. Okay, so let's find out. We have to find anyway the cube root of 19683. So let's do the prime factorization. Now will it divide by 7? Because if a number ending with 3, there is a high chance its cube root will end with 7. So 7. Now 7. Oh, okay. See the choices. Sometimes you have to look at the choices and figure it out whether which choice will be the correct one. You know that. So we have to find the cube root of y. We have to find the cube root of y. Okay. And what is y? Y is the cube root of 19683. Y is the cube root of 19683. So a number which ends with 3, its cube root has to end with 7. Its cube root has to end with 7. So because there is no other digit, if you take its cube, it will end with 3. It will end with 3. The only digit, if you take its cube, is ending with the 3. That is 7 into 7 is 49, and 49 into 7 is, it will end with 3. So so since it is the number 19683 is ending with 3, its cube root has to end with 7. So this implies that y ends with digit 7. Now then if y ends with the digit 7, then we have to ultimately find the cube root of y. So this implies we have to figure it out what will be the ending digit of cube root of y. We know that y ends with digit 7. Why? Because we know that y is cube root of 19683, and the 19683 is ending with the digit 3. So any perfect cube, if it ends with 3, if you just by observation you will notice that its cube root has to end with the digit 7. So we can say that the number y will end with the digit 7. But now we have to find the cube root of y. We have to find the cube root of y. So if y ends with 7, it ends with the digit 7, what can its cube root ends with? What is the digit that its cube root, that is cube root of y, will end with? So the choices are the choices are all the ending digits of the choices are 13. So if you take 13 cube, it will end with a digit 339. 3 into 3 is 9, and again it will end with 7. So 13 can be a possible choice. And if you now, so y ends with the digit 7, so we are trying to figure it out. What can the cube root of y, cube root of y, we are trying to figure it out, the ending digit of cube root of y, ending digit of cube root of y. Okay, so okay, so 13 cube we can see is that 13 cube is ending with the digit 7. 13 cube is ending with the digit 7. So 13 cube can be a possible choice, correct choice, but we do not know yet, because 13 cube has to be equal to y. 13 cube has to be equal to y. And what about 17? 17 cube, if you do 17 cube, it will end with the digit 3. But so it cannot be a choice, because 17 cube, if 17 is the answer, then 17 cube will be equals to y, and we know that y is ending with the digit 7, and 17 cube will end with the digit 3. So this is a wrong choice. This can possibly a correct choice, but again a 3 cube, the choice C is 3. 3 cube is 27, which is ending with 7, but 27 seems to be a so 27 cannot be the 27 cannot be the let me check. If C is the correct choice, C that is 3 is the correct choice, then it will mean that cube root of y is equal to 3. Cube root of y is equal to 3, which will mean y is equal to 27. Y is equal to 27, which means that the cube root of 19683 is 27. So this can also be a possible choice, but we have to see. And the choice D is is 9. Now if 9 is the correct answer, which means that cube root of y is 9. That is what so y will be 9 cube. Y will be 9 cube, and 9 cube will end with digit 9, which cannot be the case, because we already know that y is ending with the digit 7. So choice D cannot be the choice. So the two possibilities are choice A and C. Now C, if C is the correct choice, then we can, now if A is the correct choice, which means that cube root of y is equal to 13. Cube root of y is equal to 13. For if A, it means that choice A is meaning that cube root of y is equal to 13, because eventually we have to find the xth root of y, that is y to the power 1 by x, and we have already found x to be 3. So we have to find y to the power 1 by 3, which is equal to cube root of y. So if the answer is choice C, if the answer is choice A, then it means that cube root of y is equal to 13. This implies y is equal to 13 cube. This implies that and we know that y is the cube root of 19683. So this will mean that we know that y cube is equal to 19683. So this will mean that 13 cube and whatever this number is, that whole cube is equal to 19683. But the left hand side, 13 cube and that's whole cube, 13 cube, the number 13 cube will obviously have three digits, and a three-digit number, if you take a cube of three-digit number, then the result will obviously be minimum 6 digits, and the number 19683 is of 5 digits. So the correct choice is C. C is the correct choice. C is the correct choice. You can verify if C is the correct choice, which means that cube root of y is equal to 3. This implies y is equal to 3 cube, that is 27. This implies 27 cube, since y is the cube root of 19683, which means y cube is equal to 19683. So 27 cube should be equal to 19683. This you can verify. So you can quickly verify 27 multiplied by 27 is 49, and 14 18, and we have 54. So 9 12 and 729. Okay, 729 multiplied by again 27. So 63, 14, 20, 49, 51, and we have 18, 5 and 14. So this is 3, 8, 6, 9, 1. Okay, so it is 19683. So we see that 27 cube is 19683, which means that y is 27, which means that cube root of y is 3. So the correct choice is C. Okay, let's do problem number 10. Let's do the last problem, which is problem number 10. It is given A is equal to twice B, B is equal to 4C, and we have to find the value of cube root of A square divided by 16BC. Okay, A square divided by 16BC. Now I will there are various ways of solving a mathematical problem. You can either the basic idea is that you have to express all the three unknown, the three variables A, B and C in terms of only single variable. Either you express A and B in terms of C, or you can express it is better to express A and B in terms of C. You can also express B and C in terms of A. But let's say we express A and B in terms of C. So B we already know is 4C. So what will be A in terms of C? A is equal to twice B. Now B we know is equal to 4. B is we know is equal to 4C. So this becomes A equals to 8C. Okay. So now this becomes cube root of A square divided by, we have 16, and we have what is B. B is 4C, and we have C is C. C is C. Now this is equal to cube root of what is A? A is 8C. So 8C square divided by, we have in the denominator 16 into 4 C into C, which is 64 C square. So this is equal to cube root of 8C square becomes 64 C square, and we have 64 C square, which is nothing but cube root of 1, which is equal to 1. So the correct choice is choice A. Now there was one problem which I have marked as question mark, which I couldn't solve, or maybe the the result was not matching with the answer was not matching with the choices given. Which was that now problem? Okay, so question number 3. Question number 3 was asking, let 25920 into n be a perfect cube. Okay, then what is the smallest value of n? So we have to just, it is a question of finding the least number by which 25920 must be multiplied to make it a perfect cube. So we have to find the prime factorization of 25920. Let me check if I did it correctly or not. 25920 divided by 2 gives 12960. Okay, and 2 again divided by 2 gives 6480. Okay, and then we are again dividing by 8. Let's see, instead of okay, so 3 into 5, then what is the smallest value of n? It is asking the smallest value of n to be multiplied. Okay, so 6480 when divided by 8 gives 810, and 810 when divided by 9 gives 90. 91 divided by 9 gives 10, and 2 and 5. So the prime factorization becomes, we can see 3 2's, that makes the first triplet, and we also see 8. 8 means 2 into 2 into 2, that makes the second triplet, and we can see 2 9's. 2 9's, so 2 9's. So 2 9's is 3 into 3 into 3 into 3. So we are having a one triplet, the third triplet of factors of 3. So 1 3 is left behind, and we are having again 5. We are again 5. So 3 and 5 are the prime factors which are left behind, that is, they are not part of any triplet. So basically the answer should be to make the factors, to create triplets from 3 and 5, we have to multiply it with the number 3 square and 5 square, that is 9 into 25. So the n should be 9 into 25, which is 225, and it is not there in the choice. There is a choice 15, which is 5 into 3. Now if this question would have been what is the least number by which, if it was 25920 divided by 9, and what is the least number, what is the smallest n that will make it a perfect cube, then the answer would have been 3 multiplied by 515. Anyway, I don't know, I might have done a mistake in copying the question from the source, either the choices or even in the problem statement. It could be a mistake. I'm sorry for this. So anyway, this brings to an end in solving the sample test paper 2. I hope these sets of these problems will give you a good evaluation of your understanding on the chapter of cubes and cube roots, and it will help you to understand how the concepts of cubes and cube roots are applied to solve a little harder problems. So if this video was beneficial to you, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So the next with this sample test paper 2, it brings an end to the chapter of cubes and cube roots, and I will move on with the next chapter, that is playing with numbers, but I will keep on making 10 good problems of all the chapters that has been completed in the playlist Maths 8 Hot. So please watch out for my the new videos that will be uploaded in that playlist Maths 8 Hot for all the chapters that has been completed of class 8. So thanks for watching, and until the next video, take care and bye.